So somebody asked me about a problem where we are trying to come up with a complex number that has some conditions on it. And so it's asking us to think about complex numbers like this in our polar form, re to the I theta. And the first problem asks us to figure out what does z have to be so that if I go z times this, that I end up with a number that is a real number and that it is less than 3. Okay? So what we should do is make both of our complex numbers in the same form. So I'm going to convert this to re to the I theta. So the r is going to be the square root of the real part squared plus the imaginary part squared. And the number negative I is just one step away from the origin, so you could think of that as 1 squared, or you could think of it as negative 1 squared. Both of those are fine. The point is that it is 3 plus 1 steps away from the origin, which is the square root of 4, which is 2. So if you went root 3 over and 1 down, you would be diagonally 2 steps from the origin. The theta is the arctan, the inverse tangent of y over x, negative 1 over root 3. If you think about that, that is short and wide. It went down less than it went over. So that's like a 30-degree angle, negative 30 degrees because it has a negative y value. So I'm going to call that negative pi over 6. So now my problem becomes z multiplied by 2 e to the I negative pi over 6. And when we multiply there, we know that the r value from z multiplies by 2. So I have 2r. And we know that when you multiply one exponent by another exponent, you add the powers. So we have r e to the I, and our new power is theta plus negative pi over 6. And what we're asked to do is to end up with a real number that is less than 3. And so there's two possibilities for it to be a real number. Theta can be over here, where theta is equal to 0, or 2 pi. So I guess there's an infinite number of possibilities, but they're all kind of two possibilities. This is where theta would equal 0, or it can be over here where theta is 180 degrees, where it's pi. So there's two conditions that I can make on my theta. I could say theta minus pi over 6 equals 0, in which case, maybe I'll call this theta 1, is pi over 6, and I could add any multiple of 2 pi to that. So this is one of those questions where there's many different correct answers. The other option is that theta, I wrote that wrong. Theta 2 minus pi over 6 is equal to pi. That's what I meant to write. And then in that case, theta 2 would be, I guess, 7 pi over 6. And now let's think about both those possibilities. If I'm in this first one where I'm on the positive axis and I need a real number that's less than 3, then I need 2r to be less than 3 because that's the distance from the origin. So r needs to be less than 1.5. So if r is less than 1.5 and theta is pi over 6 plus any multiple of 2 pi, then I've satisfied the conditions. If, however, theta 2 is 7 pi over 6, then I'm already on the negative axis. So r can be anything positive. R could also equal 0. The only issue would be if r was a negative number, and if that negative number became like negative 2, it would flip me over to the wrong side. So in this case, I just have to say r is anything bigger than negative 1.5 for the same reason as before. So that was one part. The next part to this question is very similar, so I'll go a little quicker because it's just, I don't have to explain all the steps again. We're asked to figure out what conditions are there on r and theta such that this expression is imaginary and it has the modulus greater than 4. So let's do the same thing. This has an r value of square root of 1 plus 1. This has a theta value of arctan of 1 over negative 1. And I know that it went left and up because the real part's negative, the imaginary part's positive, so I guess that's like 135 degrees. I guess that's 3 pi over 4. Be careful because I just want to point this out. If you grab your calculator and you do the arctan of negative 1, it tells you negative a quarter pi, so you have to add pi to it because, again, arctan, I think I've explained this before, arctan has a range here, but we knew that our complex number was right there. So arctan tells us this angle of negative pi over 4, but if we add pi, we end up over here. I usually just visualize it as 3 pi over 4. Anyway, now we know that the r and the theta from z multiply, so we have root 2r, e to the I, we add the angles, so we have theta plus 3 pi over 4. We need it to be imaginary with a modulus of 4. Two options. We're up here on the positive y, we're down here on the negative y. So first option, theta 1 plus 3 pi over 4 is equal to, on the positive y-axis is pi over 2. So theta 1 is, I guess, negative pi over 4. Plus 2 pi or plus 4 pi or minus 16 pi. Theta 2 plus 3 pi over 4 is negative pi over 2 or 3 pi over 2. Either one's fine. So I get theta 2 is, that's 2 over 4, negative 5 pi over 4. If I do theta 1, then I need to have my modulus greater than 4. So root 2r greater than 4. R is greater than 4 over root 2. Or 2 root 2 if you want to simplify that. So that's R1. On the other one, same idea. Same for R1 and R2. All right. Let me know if you have any questions. Happy to help out.